In this video, we conclude our discussion on Chapter 7, where in our last video we began our discussion of costs from production for a firm. In today's video, we seek to conclude this discussion by setting up some preliminaries to discuss average costs, then conclude with the long run. Beginning with our preliminaries, currently we are seeking to develop a framework to explain how firms make decisions, where we need to answer how does the firm produce goods and services, what costs does the firm incur with production, as well as how much does the firm generate with the sale of its goods and services. Thus far we have answered question 1 through the production function, where we saw the properties of the production function as well as its rate of change through the marginal physical product, and we have began discussing question 2 in our last video through our discussion of costs and total cost, where we now know that total cost is the sum of fixed and variable costs, and we know their properties graphically, and we saw the rate of change of total cost through marginal cost, which is upward sloping due to diminishing returns on labor. Now we seek to continue this discussion on costs by considering average costs. And to do so, we will derive where average costs come from, which we can do so by dividing cost by output produced. So let us begin with total cost is equal to the sum of fixed and variable cost. If we divide both sides, the left and right hand side, by output produced, we'll have total cost divided by output produced, which is going to be equal to 1 over output produced, scaled by our sum of fixed and variable cost. Simplifying our left hand side, this leaves us with average total cost is now equal to the sum of fixed cost divided by output produced, plus variable cost divided by output produced. We can then further simplify this, and this leaves us with average total cost is equal to the sum of average fixed cost and average variable cost. So then, with our average cost structures derived, let us see if we can examine their properties. And to do so, we will examine our firm that cleans cars as before. So let us begin with average fixed cost. We have a graphical representation on the right, where cost will be on the vertical axis, cars cleaned on the horizontal axis, and we'll have a table representation as well for a particular point, the cars cleaned, as well as our fixed cost and average fixed cost component. So in terms of this, we will also be attaching some numbers so that we can get a numerical account for what's going on as well. So let us assume that fixed costs for rent and for fees for the space that's being used and the cleaning equipment for the firm will be $150. Additionally, we know that our average fixed cost formula in our derivation is going to be fixed cost divided by total output. Now looking at our graphical representation, we can see that we have a downward sloping average fixed cost curve. So let us see if we can explain why that is. The first thing that we should observe in terms of our numerator is that fixed costs stay constant throughout, which we observed in our discussion of total cost, where if we look at our table representation, we know that this firm is paying $150 for the use of the space and its cleaning equipment. And regardless of the cars that they are cleaning, they have to pay the $150 regardless. So we have a static fixed cost. Now, in terms of our denominator of total output, we know that as more labor is being used, more cars can be cleaned, because in our production process, more inputs leads to more outputs. So we know that cars cleaned is increasing with more labor. So we have a static numerator and we have an increasing denominator. So then what that means is that we have average fixed costs that will be declining as a result. So average fixed costs will slope downwards due to cars cleaned increasing while fixed costs staying constant. Now let us move on to average variable costs, where same thing. We'll have a graphical representation above, cost on the vertical axis, cars cleaned on the horizontal, table representation for a particular point, cars cleaned, labor used, variable costs, and our overall average variable costs. Now, assigning a numerical value, assume that wages for each employee used for labor will be $50. That is, each unit of labor that's used, the firm has to pay that unit of labor $50 in terms of wages. Now in terms of formula, we know that the average variable cost formula is going to be variable cost divided by total output. Now in terms of our graphical representation of average variable cost, we see that it's upward sloping. Let us see if we can explain why by examining variable costs and total output. Starting with our numerator, we know that variable costs will increase as more labor is used. In terms of the production process, more labor, more cars can be cleaned, more input leads to more output. But in terms of variable costs, that also means more wages. We've seen that variable costs are increasing, and we can see that in our table representation as well. As we go from point B, in which here we have labor being 1 unit all the way up to 5 units, we see that variable cost is increasing as well by $50, given that the wage rate is $50, and each unit of labor that we're using will add additional $50 in terms of costs. So we have an increasing variable cost structure. And then now moving on to our denominator of total output, we also know that as more labor is being used, cars cleaned will increase as well due to more input leading to more output, which we can see in our table representation as well. Labor increasing, we can see cars cleaned increasing as well. So what we then have is a denominator that's increasing and a numerator that is increasing as well. But due to diminishing returns on labor, we'll have that the increases in variable cost will outweigh the increases in total output. So with the numerator dominating in terms of its rate of change, we'll have an upward sloping average variable cost curve as we see. So then with average fixed cost and average variable cost considered, let us now consider average total cost, where we have our graphical representation on the upper right and our table representation on the bottom right. We have our points, cars cleaned, average fixed cost, average variable cost, average total cost, as well as labor used for each particular point. Now we are still assuming that we have our $150 in terms of the fixed cost of the rent and fees, and the $50 in wages for each employee used in regards to labor. We also know that our average total cost formula is going to be total cost divided by total output. And in terms of our graphical representation, we see that average total cost is U-shaped. Let us explain why that is by incorporating our average variable cost curve in blue that is upward sloping, in addition to our downward sloping average fixed cost curve in red, to also see this in accordance with our U-shaped purple average total cost curve. So on inspection, we can see with respect to average total cost, at point B all the way up until point D, we see that average total cost is downward sloping. If we look down at average fixed cost and average variable cost, we see up until point D that average fixed cost is greater than average variable cost, where average fixed cost is downward sloping. So since it is the dominant cost effect, since it's greater, this is going to be reflected in average total cost and it being downward sloping. We can see this in our table representation as well. At point B up until point D, we see that average fixed cost is greater than average variable cost at those points up until point D. So then we see that average total cost as a result is downward sloping up until that point as well. So then we have that average total cost will be decreasing when average fixed cost is greater than average variable cost, where upon inspection we see that at point D, this is when average fixed cost and average variable cost intersect. So this is going to correspond to a minimum point in regards to average total cost, which we can see holds true in our table representation, where $17.32 is going to be the smallest amount in terms of average total cost given points B up until point F. So then lastly, we see from up until point D until we go to point F, we see that average total cost is upward sloping. Looking down at average fixed cost and average variable costs, we see from up until point D along till we go to point F that our upward sloping average variable cost curve is above or strictly greater than our average fixed costs. Since average variable cost is upward sloping, this is going to reflect in average total cost and it being upward sloping as well. We can see this in our table representation as well. And then at point E and F, we see that average variable cost is greater than average fixed cost, And we see from point D onwards that average total cost is increasing as a result as well. And since these three cases were exhaustive, this then explains why average total costs are U-shaped as a result. And if we want to take things a bit further, we can incorporate marginal costs as well, where in our graphical representation we now have average total cost, average fixed cost, average variable costs, and our upward sloping marginal cost curve. Where recall that marginal costs will be increasing due to diminishing returns. And in terms of incorporating this into this cost structure, we can observe two things. The first is that marginal cost will intersect average variable cost at its minimum, and that it will also intersect average total cost at its minimum as well. So we can restate why average total costs are U-shaped by incorporating marginal cost as well, where when average total cost is greater than marginal cost, it will be downward sloping, whereas when marginal costs are greater than average total cost will be upward sloping. So then, to summarize what we saw in terms of these average costs, average fixed costs are downward sloping, whereas average variable costs will increase due to diminishing returns, and average total costs are U-shaped and will decrease or increase depending on if average fixed or average variable costs are more dominant, and that in regards to marginal cost, it will intersect average variable cost and average total cost at their minimums, and we can restate why average total cost is U-shaped by reflecting its relationship with marginal costs. So then, with our discussion on cost complete, where we would like to conclude today is by considering the long run, where up until now we have considered short-run production. Let us now consider long-run production, where recall this means that all our inputs will be variable. Since we're considering a firm that's using labor and capital, that means labor is going to be variable as before, and now capital will be variable. That is the location size where they're cleaning the cars, as well as the cleaning equipment. And so by letting labor and capital now be variable, the firm has the ability to choose its staffing size, location size, and cleaning equipment quota, where we have this reflected in the production function below in table form, where we have units of labor, units of capital, and we have cars cleaned given a particular combination of labor and capital being used, where we see that if labor is 0, regardless of the capital that's being used, cars cleaned will be 0. Likewise, if capital is 0, regardless of the amount of labor that's being used, cars cleaned will remain 0. And in terms of the production function that we were initially working with, we were assuming 1 unit of capital in terms of the small location size, as well as cleaning equipment quota, and varying amounts of labor from 0 units of cars cleaned up until 22.36 units of cars cleaned. Where we see now the firm has the ability to vary their capital from 2 to 3, and as they vary labor, we see that at particular steps, with more labor, more cars can be cleaned, and more cars can be cleaned than if fewer units of capital were used. We can see that comparing 2 to 1, and same thing from 3 units of capital to 2 units of capital with varying amounts of labor as a result as well. So with this variable choice in capital now, we have seen that with variable labor, with more labor entails more wages, thus more costs. The same will be true with capital, in that by choosing to increase their location size, the firm will have to commit to higher rent and will face more costs as a result. Likewise, if they choose to increase their cleaning equipment quota per month, then with more materials will lead to more costs. And so with more use of capital through a larger location, then the firm will also be able to produce more though, which will let them face a lower average total cost structure than they could before. And lastly, similar to what we saw with short-run production, there will be a case in which the long-run marginal cost curve will intersect the long-run average total cost curve as well.